Good morning, students. We were doing electrolysis of molten lead bromide. Today we are going to start with electrolysis of acidified water using platinum electrodes. Now, what is the electrolyte you have chosen? Acidified water. That means pure water. To it you have added traces of sulfuric acid. Now, why didn't you choose pure water, or let's say ordinary water? Because pure water is a poor conductor of electricity, is a non-electrolyte. Now the electrode, cathode, is the platinum foil which is connected to copper wire to the negative terminal of the battery. Anode is also a platinum foil which is an inert electrode. That means it does not take part in the chemical reaction, connected to the positive terminal of the battery. Now let us look at the electrolytic dissociation of acidified water. Dissociation of acidified water. H2O will form H positive ions and OH negative ions. And sulfuric acid will ionize into two hydrogen ions which are always positively charged and a sulfate ion which is always negatively charged. Now let us quickly look at the reaction taking place at the cathode. You know that cathode is the negative electrode. So the positive charged ions will migrate towards the cathode. So H positive ions, it gains one electron from the cathode and gets discharged. So hydrogen atom is formed. Two hydrogen atoms combine to give rise to hydrogen gas. So colorless gas is given off at the cathode. Now the reaction taking place at the anode. Hydroxyl ions are negatively charged, so it gets attracted towards the anode. It loses one electron to form hydro OH atoms. Now 4 OH atoms will combine to give you two molecules of water and oxygen gas, which you know is a supporter of combustion. Now let us look at the reaction. At the cathode, gain of electron is taking place, so we call it reduction reaction. At the anode, loss of electron is taking place, so what do we call? Oxidation. So electrolysis is a typical example of oxidation and reduction reaction, which we call redox reaction. Now, electrolysis of water gives two volumes of hydrogen gas and one volume of oxygen gas. So what are the products formed? Two volumes of hydrogen and one volume of oxygen. Hydrogen will collect where? It will collect at the cathode. Oxygen will collect at the anode. Now, pure water is almost a non-electrolyte. As such, addition of dilute sulfuric acid help in dissociating water into H positive ion and OH negative ions. Hence, electrolysis of acidified water is considered as an example of catalysis. Is that clear? The third experiment is electrolysis of copper sulfate solution, which we also call aqueous copper sulfate, using copper electrodes. So both the anode and the cathode is made of copper, and you know the copper electrodes are active electrodes. They take part in the chemical reaction. So the electrode reaction, look at it. Copper sulfate solution. So CuSO4 dissolved in water. CuSO4 gives rise to cupric ions Cu2 positive and sulfate ions SO4 negative. Then water will decompose into H positive ions and OH negative ions. Reaction taking place at the cathode. Cathode is negatively charged, so the positive charged ions, cupric ions and hydrogen ions get migrated towards the cathode. However, only one will get discharged, and that is cupric ions. Why? Because it lies below hydrogen in the reactivity series. So cupric ion, it gains 2 electrons from the cathode and gets discharged. So pinkish, reddish, pinkish, or you call it brownish red copper metal is deposited on the surface of the cathode. Now the reaction taking place at the anode. The anode itself is made of copper. Okay, the anode itself is made of copper. So it will take part in the chemical reaction. It loses 2 electrons and forms cupric ions. Thereby it increases the cupric ions concentration in the solution. Now, what do you observe? The blue color of aqueous copper sulfate solution remains unchanged when you are using copper cathode and copper anode, since cupric ions is added to the solution because of copper electrodes. As such, the color, the blue color of the solution does not fade away. Is that clear? So please revise the electrolytic dissociation reaction. What are the products formed at the cathode and what are the products formed at the anode, and what you observe. Thank you.